Okay, so we're going to take a look at the second type of problem when we need to solve for equilibrium concentrations. So in this question, we're reacting hydrogen, fluorine, and we're going to create hydrofluoric acid from that. We know that equilibrium constant is 1.15 times 10 to the 2, and we have initial concentrations of all three of our products. And here we just asked to calculate the equilibrium concentration for all of these species. So just like always, our first step is going to be writing a balanced chemical reaction. So it's telling us that we're starting off with elemental hydrogen. So elemental is just saying that I have a single type of element, so just hydrogen. Thinking about what hydrogen would look like, it only has one electron. Since hydrogen is in column number 1 and row number 1, it has one shell, one electron in that shell. So for hydrogen to be full, I need 2 electrons. Elemental is telling me I only have a single type of atom. So for hydrogen to get full, I would need to add another hydrogen. And if I do that, they can covalent bond, share an electron, and they have that 2 electrons to be full. So I know this has to be H2. It's telling us that they're in the gas phase, so gas. And I'm also mixing it with elemental fluorine. Same idea for fluorine. And if you check that, it should be F2 gas. And from that, I'm going to create hydrofluoric acid. So hydro means H, fluoric F, so it's going to be HF. And that's also gas. But this has a equilibrium. So that keyword right there, equilibrium, is telling me that this reaction is going to be an equilibrium reaction. So I can draw like the forward, backward arrows. So from here, I can go ahead and balance this. In order to balance it, since I have 2 H's and 2 F's on the left side, I just need to add a 2 to my right side. So I'm just going to drag this over, make a little bit of space for myself. And I'll put my 2 right there. So now it's balanced. So that's step 1. Step 2, just like for the first type of ice table questions, my second step is to get molarity from my given values. So I know molarity is going to be moles over liters. And here in this question, it's telling me that I have 3 moles of all 3 components. So let's run through, set that up really quick. So I have H2, I have F2, and I have HF. So from these 2, I'm starting off with 3 moles of each. So 3 moles. And from this, I'm going to divide it by the liters of like whatever liquid we are inside. So for here, I see I have a 1.5 liter flask. It's going to divide this by 1.5. So if I do that, I should get 2 molar concentrations for all of these. So that's going to be step number 2. Now, in step number 3, I'm going to set up my ice table. So I'm going to copy down my reaction first. So I have H2 plus F2. It's going to turn into 2 HF. I'm going to draw my line. Draw my line. And then for my ice table, I'll make a row for each of those. So I is for initial, C is for change, and E is going to be for equilibrium. I like to separate, seeing that I have H2 and F2. I have 2 different reactants. So I'm going to separate my reactant side with like a little squiggly line. So from here, I can go ahead and plug in my initial concentrations first. So I have M2. I'm going to go and plug in my M2 values in those initial concentration spots. So I'm going to be filling in 2. Now what I got to do is I got to figure out what my change is going to be. So for my change, I know that value is going to be X. I'm not sure if I'm going to be adding it or taking it away yet. So I'm just going to throw in X for all of my changes. So now for change, one has to be positive, the other has to be negative. So either I'm adding more reactant or I'm taking away more reactant. This is going to be how we figure it out. For this type of reaction, since I don't know any of the equilibrium concentrations, I have to look at my K value. So my equilibrium constant is 1.15 times 10 to the 2. So let's copy that down here. Kc, 1.5 times 10 to the 2. If I kind of expand that scientific notation, I should get 150. So I need to remember that this 150 is my product concentration over my reactant concentration. So I know this very large Kc, this is product favored. Or I'm going to have way more product than reactant. That's what like a large Kc means. So what this is telling me is I should be increasing my product side. So because of this large Kc, this tells me that this is a positive or an increased X. If I'm making more product, I'm increasing my right side, I have to get that increase from somewhere. So that means I have to be decreasing or losing reactant. So they're going to be negative numbers. Now what I'm going to do, I'm going to come up and I need to see my ratios for that change. So I see that 1 H2 and 1 F2 is going to make 2 HFs. So that means for every time that my H decreases by 1 and my F decreases by 1, my HF should increase by 2. So all I'm doing is I'm taking those coefficients and I'm bringing them down. So now what I'm going to do is figure out what my equilibrium should be. So I'm just going to add up the column. So for H2, I know that I start at 2, but then I decrease by whatever 1x is. Not sure what it is. I have like a number and a variable. I can't combine those, so I'm just going to bring the whole thing down. I'm going to do the same thing for F2. It starts at 2, and it's going to decrease by 1x. Now, looking over at my product side, my HF is going to start at a concentration of 2, but now it's increasing by a factor of 2x. So that's going to be my setup ice table. Having this 2-part, and then breaking down and bringing down the rest. So that's going to be step number 3, just setting up your ice table. Now, in step number 4, it's going to be a little bit different from the first part we did in class. So here in this ice table, I have no way of figuring out what X is equal to because I don't have the initial and equilibrium concentration of like one of these chemicals. I have like an X variable for all of them. So because of that, we're going to do something a little bit different. Now what I'm going to do is I'm going to set up my general equilibrium expression. So I'm going to say Kc is equal to the concentration of HF at equilibrium over the concentration of H2 and F2. I'm going to bring down my coefficients. I see that up here, H2 has a coefficient of 2. So I'm going to square this product part. Now from here, what I can do is start plugging in some variables. So we're going to call this step number 5. Oh, and big idea here, general equilibrium expression is just your products over your reactants. So step number 5, I'm going to plug in to my Kc, my general equilibrium expression. So instead of using Kc and solving for Kc like we do before, we know that Kc is 1.5 times 10 to the 2. So I'm going to plug that number in. 1.5 times 10 to the 2. We also know that at equilibrium, we have the HF concentration. We know that it's 2 plus 2x. I don't know what 2x is yet. I'm just going to plug in what we do know. So I'll plug in 2 plus 2x. And remember my expression, I'm squaring that. So I'm going to square that value as well. Just sticking with the color coding, we're going to make that red. Now, for my reactant side, seeing this, I see I have two numbers. I have, we'll do blue for this. I have 2 minus 1x and 2 minus 1x. So from here, I'm going to do 2 minus 1x and then 2 minus 1x. And those were those blue highlights. So here, we're going to have a couple different ways to solve this. I'm going to set it up and solve it kind of the long way first, and then we'll talk about different shortcuts in order to solve it. If you're super confident in your math skills, like your Algebra 1 skills, you might already see a possible shortcut for this, but we'll kind of work through the long way first. So first thing I'm going to do is I'm going to take a look at this bottom part of my fraction, and I'm going to multiply those two together. So I'm going to bring down my 1.5 times 10 to the 2. I'm going to leave my 2 plus 2x squared on top, but we're going to combine the bottom part. So I'm going to say 2 times 2 gives me 4. 2 times negative 1x gives me negative 2x. And then now I'm going to take this second half. So let's do that in a different color. I'm going to take my negative 1x times 2. That gives me negative 2x. And my negative x times negative 1x. That's going to give me a positive x squared. And then if I continue, now I'm going to try to solve the top part. I'm going to do this red section next. So I have 1.5x times 10 to the 2. I'm going to keep my bottom part that we just solved for. 4 minus 2x. I'm going to combine these two. I'm going to simplify it so that I see I have, let's do this part. I see I have negative 2x, negative 2x. So I can combine those two numbers and make negative 4x. And I'm going to add my x squared. So now I'm going to try to solve that top part, that red part first. So now I'm squaring that. So I'm going to distribute that to 2 squared. It's going to be 4. And then I have my 4x squared. But remember that this is really saying I have 2 plus 2x. So it's like we did this first part. 2 times 2, that gave me the 4. This 2 times that 2x, that gave me 4x. This 2 times that 2 gave me another 4x. And this 2 times that 2, that gave me the 4x squared. So we have those two parts. We're just not including that 4x and that 4x. So I need to make sure I add my 8x at the end. So once we get here, now we're going to try to get everything to be on the same side. So I'm going to take this whole bottom part, and I'm going to multiply it by both sides. And you can kind of see where we're going. If I were to continue this question, I'm going to make this kind of crazy looking quadratic. So just to save us a little bit of time, if you are struggling with like the math part for the quadratics, just make sure you come into tutoring and I can help you with this part. But if you keep going and you solve that stuff, you're going to get 1100 x squared minus 468x plus 456. And that should equal 0. So this is going to be the quadratic that you make from that. Bunch of steps to do that. Gets kind of complicated, and if you're not super confident with your math skills, a lot of places that you could mess up. But that is the easiest place to go. And then from there, it's just like a regular quadratic formula. You have your A, your B, and your C. And you just plug that into the quadratic formula. So you plug into something like that. And from here, you're just going to be plugging in each of those. So your A, your B. So it's going to look something like this. So that's what it'll look like. When you solve that, you can plug in and you can solve. I'm assuming you're able to do that. And we are going to get the following two questions. The following two numbers. We're going to get 1.5. Oh, you're good.
Are you doing something?
Yeah.
Are you online or something?
No, I was recording a video.
Oh, I'm so sorry.
No, you're good. What's up?